our model is going to include all sorts of different kinds of energy, so I thought I would just mention them here. We'll talk about thermal energy. Thermal energy is what changes when the temperature changes. So when I added heat, now I'm going to take heat out. So I'm going to put something cold in contact with this. This cartoon is putting something cold in contact with this gas. The gas temperature goes down as I transfer heat energy away from the gas. The thermal energy is what goes down. I can tell that because the temperature goes down. Now, other kinds of energy, bond energy, chemical bond energy. Can I change chemical bond energy? Well, that happens when you get a phase change or a chemical reaction. Now, I happen to be using argon. Argon's an inert gas, and so there isn't going to be a chemical reaction that's all that interesting. There isn't going to be a chemical reaction, but I could get a phase change. If I cool this argon gas off enough, then the argon molecules will have low enough energy that they start noticing that they attract each other. And in fact, if they don't have very much energy, they will start to stick together. It's the energy that pulls them apart. They start to stick together, and I'm going to heat them up just a little bit, because what I want you to see is that that looks like a liquid down there at the bottom. It doesn't have a constant shape. Its shape is changing around, and its shape is determined basically by the shape of the bottom of the container. So when I cool this thing off, they attract each other. I have a phase change. When you have a phase change, you know that bond energy has changed. These atoms were earlier, they were far from each other. They weren't sticking together, and now they're stuck together. This one right here, I can follow around, and it's stuck to a bunch of neighbors, and it never gets very far, so it's bound to those neighbors. There's a lot of them bound together here. Every once in a while, one of them picks up enough energy to fly off, but it bounces around and eventually comes back. So there's a kind of average number of bonds being made here. If I cool it off more, then you know what happens? Make another phase change. This is to a solid. And for this one, in the solid, the number of bonds is close to the total number that I could make. And there's just no way to make any more bonds. None of the atoms are now flying around. They don't change their location very much. If I watch this one right here, it's surrounded by 6 more. They don't change its location very much. Other kinds of energy, kinetic energy, if I picked up this is now a solid chunk of argon, really cold, 21 Kelvin. A solid chunk of argon. If I picked that up and threw it across the room, then I would have given it some energy. It would have a speed. So that's a kinetic energy we'll talk about later. Various kinds of potential energy depend on the location of the objects. Other things you can name, nuclear energy. These argon atoms have nuclei. So the nuclei are made up of protons and neutrons, and they're stuck together, and there's an energy associated with that. There's also atomic energy. So there are other energies that we could talk about, but we're not going to right now. Right now we're going to focus on thermal energy. Depends on the temperature, and bond energy depends on phase changes.